G'day, Michael here. I'm making more progress on the CoreXY. This is really the main block for the Z-axis, X-axis interaction. Let's have a look at the computer. Okay, now this is, well, basically an overview of the whole. Well, there's the original design of most parts. I've dropped a few ideas and I've added a few others. These are the parts laid out ready for printing, and these are the current design. This is the piece that's in the machine right now being printed. This is a new component which will have various elements added to it, I think. Don't know quite yet. I will have to modify the motor, well, the motor mount is modified, and the dual idler corner blocks, I'll have to make a differing left and right to avoid some of the friction between the belts, and also to make the idler pulleys run more efficiently. These components here are basically a larger diameter idler that I've sort of developed, and they work rather well, but I'm going to try and stick with all metal parts if I can. And you know, we'll have a look at the real parts now, I guess. Probably the easiest thing. Righto. Right, now these are the idlers. What I need to do, as they form a crossover at the back, I need to basically tilt them towards each other to minimise, you know, the funny tension on the belt. Come on, focus. So this top pulley has to be angled down to meet its counterpart on the other end, and this one has to be angled up to meet its counterpart on the other end. So it's probably, you know, I don't know, 2 or 3 degrees. I haven't calculated it yet, but we'll have to have a little bit of a modification. And I'll also have to have a little bit of offset to allow for that to tilt without actually chafing on the block here. The other thing I have to do is, looking from above, the two belts actually rub in the center as they pass each other. So I'll have to change the position of these pulleys a little bit so one can operate behind the other without actually chafing. So that's something I've learned. The motor mount modification I've made is this component here is made thicker, so there's less deflection. It's adequate, but I prefer to do a better job of it. Alright, what else have I done? Okay, I've added my first limit switch, and I've played with the Arduino controller and found, you know, the basic things actually work okay. I've played with some limit switches which are just dangling loose around the place. I've yet to program it for CoreXY, but now I guess I can move on to the other bits and bobs. I'm going to be having 2 power supplies on this unit, one for the kinematics or the motion, and the other one for the hotbed. Now in a typical Prusa you have this kind of a hotbed. Well, I'll need a fair bit more because I'll be doing about 450. I might even squeeze out 470mm square. This kind of hotbed just won't cut the mustard. I'll show you what I have got. What I ended up getting was this guy. It's it's a silicon mat with like an element. You probably can see the trace lines there. You can see the lines there. Basically, there's an element built into the silicon, and there's a self-adhesive backing on it, so I can stick it to the aluminium plate that I'm going to use, which I've not yet cut. It's also got a thermistor built in. I might use that one, or I might use another one. And what I have to use is a separate controller that probably doesn't really show up, but it's similar to any hotbed controller. So I can get the Arduino device to switch this on and off as part of the normal run, but it'll actually be switching power from a 24 volt supply. The rest of it's going to be running on 12 volt. So the motion's going to be running on 12 volt, and this hotbed's going to be running on 24. So I will have 2 power supplies. It's also possible that I may find the stepper motors aren't quite up to accelerating the way I want them to accelerate, and I might have to beef up the stepper motor, well, stepper motors, for the X and Y motion. I'm pretty happy with the Z. That'll cope with it quite well. Now this is the carriage that goes on the X-axis, where the Z actually goes through. Now I found a few issues. These particular pulleys are not very accurately made. They're very poorly made. And through pulling them apart, I found out that the bearings are not hardened. So I've got some bearings on order. I printed these tyres for the bearings out of a, it's a PLA, but it's a rubber-like PLA. So I'm hoping that that's going to work out well. Certainly, the Z-axis doesn't have to do much work, so I'm hopeful that I'll get a suitable, wear life out of these parts. Now, this black chunk is the same as this used to be. I had to cut out these ends, so you can see the honeycomb in here. I had to cut out these ends so I can get my thread tap through to thread for these screws that hold the pulleys. That was an error in the design, so I've changed that design so it's already got that inset, and I've tapered this off this way. The other thing I've done is I've lifted these little bearings up 15 millimeters, so it'll make this more compact in the actual printer. Alright, now the Z-axis, if you'd have seen my previous video, was going to be this design, and it was actually on my CAD drawing. I've done it this way, but I decided I want to have 400 millimeters in height, so I've switched to this ball screw. It's a 1204, which means 12 mm diameter, nominal diameter, and a 4 mm pitch. I've had to pull it apart and reverse this component because I wanted the flange the other way around. But that brought me to another problem, and that was, how do I power this shaft? Now, my initial thought was actually to belt drive it, put pulley on here and belt drive it. But then the next problem is getting a belt the right size. That would still be my desirable thing because I want to place the motor closer in. But what I ended up doing, at least for the moment, is I've printed this coupling. I'll just open it apart. Now this part would go on the motor and provide a slide in one axis. It's got a 5 mm hole. Then you've got the other part which mounts on the shaft. And again, there's this part here that will mate between the two, and the slots are set at right angles to each other, as you can see there. So what this does is it provides a sort of a slide capacity in one axis with the thread end, and the other axis with the motor end. So I can have the motor in line, and if there's any imperfections, this will allow that to, well, give some tolerance. Obviously you don't want to have too much of a misalignment, but if there is a small misalignment between the motor mount and the thread mount, this can cope with that deviation. It fits fairly nicely. This would be no good for any high speed interactions because obviously being a thermoplastic, it would heat up and you wouldn't want that. But on the Z-axis it only moves a little bit, so I'm quite happy that this will give me, probably more life than the rest of the printer can anyway. So the duty cycle of this part is not demanding. Alright, so I'll get 400 millimeters of travel on that beautiful lead screw, but it meant that I have to mount it differently because this original idea was going to have the screw down the centre. Unfortunately, this nut assembly will not fit inside this extrusion, so I had to abandon the idea of having the screw inside, and I'm going to have it mounted on the outside. Here's another piece of aluminium which I'm going to be mounting the screw onto. I've yet to design those bits and bobs that will hold the motor mount and also, the bearings, etc. So that's yet to come. But I'm feeling very pleased with that. That's part of the modification I had to make here. I had to make more room for the thread to occur through this, the Z action through here. Other than that, this part worked out okay. And so essentially I've got the same design. I've just opened this out a bit, and I've had to add a bit of material on the outside here to give it some strength. Okay, now the hot end. I'm not happy with any of the hot ends I can buy. This is the very sort of common hot end. We have a very small tip. Then we have, on mostly the deltas, we seem to have this kind of it's a Bowden arrangement, but the difference is the melt length is increased. You can see how the blocks are a little bit longer, but also correspondingly the tips are a little bit longer. These actually put out a lot more material than those, as I've found. So they are good. They're almost at the level that I want. And funny enough, the volcanoes, which have got a significantly longer melt length, are not as much of a step better than these as that is better than the other. So from here to here is a fairly noticeable improvement, and from there to there is not quite as noticeable improvement, but I think there may be inefficiencies in the way these actual melt paths work out. I intend to make my own hot end, but for the moment, that's in the too hard basket. I've got too many other things to worry about. So for the moment, I'm going to use a volcano. As you can see, I've got one assembled here. Now this feeder motor, I'm actually going to be putting on the bottom of the Z-axis. I don't want this amount of weight. I've ordered some much smaller motors, and I'll be making an integrated design with my little hot end that I've yet to develop. But for the moment, this is going to be a temporary gadget with a bit of a mounting bracket. But because of the way I have to mount it, it's going to be very difficult to get access to getting the filament started properly. So what I've done is I've modified this part, so I've got the Teflon coming through to here, so that it's a fairly reliable starter, whereas they normally involved some intervention to get everything threaded through. This is now, my intention is to be able to thread from the top end of this Teflon tube, which will be at the top of the Z-axis. And just pressing this button, I should be able to prime it without too much fuss. That's my hope. I believe I've got that at this stage. I also want to insulate this quite a bit so it doesn't transfer much heat into this area. I'm aiming to have no fan at this end. This other design requires a fan. That all adds a bulk and height that I don't want to have in the design. The more I have that Z-axis sticking out with more bits and bobs on it, the more it's going to limit how much I can accelerate the X and Y axes. Z's going to be more than ample, but X and Y, I want to have really high performance. I'm aiming to go as close as I can to the Delta's performance, but it's quite technically demanding. This motor's way too heavy for that, but having said that, I should be able to get reasonable performance anyway. It should be a bit better than my Cartesians, but it won't be the same as the Delta, that's for sure. Anyway, that's, I guess, it for the moment. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.